Okie doke, next lecture is the second mechanism, alternative resource inputs and DTC. So Solo said, look, if we're running out of resource 1, why can't we just switch to resource 2? And furthermore, maybe we can then invest in, we've sort of neglected resource 2 because we didn't need it, but then when we find we need it, we can invest in knowledge about how to use it better. And that will help this transition. Okay? So, and we need to unpack that and do some modeling and so on before we can start looking at data. And in this, the last set of videos on the first mechanism was pretty involved. This time it's going to be much easier because we're going to build on what we did last time. So that was the model we had before. But now we're going to shift the focus to here, and the knowledge production is going to be here, and there are going to be two alternatives like that. Okay, so now suddenly we've got an oil sector and a coal sector according to this picture, and we've got knowledge about using coal and using oil to make energy, which is then an input into final good, just like before, R and L. But now we've got alternative inputs into the energy sector. So, and here, for simplicity, we go back to Codd Douglas. This is typical for economics, right? We keep things as simple as we can make them, apart from where we really need the complexity. And for this model, we need the complexity here, not here. So we have y is ALL 1 minus alpha r to the alpha, but r is a CES function of R1 and R2. And now, surprise, surprise, these should be good substitutes, right? They're highly substitutable for each other. There's alternative ways of making energy. Oh, should we have coal? Should we have oil? It's, oh, we've already got loads of coal. Yeah, sure, but it doesn't affect that much the attractiveness of oil, of having more coal, just because we've already got a lot of coal. It does to an extent, but not very much. They're good substitutes. Epsilon is greater than 0. Okay, instead of being less than 0, which was the case when we had labor and the resource. Okay, so there's our two key equations. What can we say about epsilon? Okay, epsilon is greater than 0. That's exactly the same. The math is the same. We end up with the same expression linking Z1 over Z2 to A1, R1, and A1, W1, so on. So we replaced L's and R's by 1's and 2's. But now we can see that, for instance, if we go Z1 over Z2, I'm just going to write out this bit, A1 over W1, A2 over W2, to the epsilon over epsilon minus 1. Now epsilon is 1 minus epsilon. Epsilon over 1 minus epsilon. Epsilon is greater than 0, but less than 1. So this is positive. So when W1 goes up exogenously, then this goes down. This is positive, so this whole thing goes down. We invest less in being efficient in using 1. So when in the previous case, when 1 got more expensive, we invested more in its efficiency, because it was like, oh wow, we're not very flexible in substituting between these inputs. One of them got more expensive. We still have to use it. We've got to get more efficient. Now it's like, oh, we're flexible between the inputs. One got more expensive. Let's use less of that one, much less, and not bother investing in efficiency. Let's just go for an input 2. Okay, this is the effect of epsilon being greater than 0. Okay, and this of course has a dramatic effect on the properties of the model if we again go for our sort of discredited idea of independent knowledge stocks. Again, we shift the L's and R's to 1s and 2s. And again, the explanation here isn't great. The point is that there's a specific value of a1t over a1t minus 1 divided by a2t over a2t minus 1 that gives balance. That means there's a specific value for z1 over z2 that gives balance. And that means there's a unique level for the relative factor shares that gives balance. Okay? Remember, the factor shares are W1 R1 over W2 2 R2, which are also equal to here A1 R1 over A2 R2 to the epsilon, and they're also equal to A1 over W1 divided by A2 over W2 to the epsilon over 1 minus epsilon. Okay, back to here. So there's a unique BGP where the Z1 over Z2 is just right to keep this balance. Okay, assuming that we've got constant trends in our exogenous variables, like say, for instance, if W1 over W2 is exogenous, we could say, oh, let's assume it's exogenously constant, or let's assume it's changing at some fixed exogenous rate. Then there's a unique value for Z1 over Z2 that will give us balanced growth. And in the previous case, we could show that that unique value was stable, that the economy tended towards it. Okay, that if this is the value that gives stability, if we move away from it, we tend to head back towards it. Okay. But here, the opposite is the case. Okay, there is a unique value that gives balanced growth, but it's not stable. Okay, if we're a bit away from it, we head off in the wrong direction. So why is that? Well, let's see what it says in the notes. Imagine we are on the balanced growth path. So the level of A1, say that W1 over W2 is exogenously fixed, and A1 over A2 is just right to give the right value of Z1 over Z2 to be balanced up on top of the hill here. Then imagine that W1 increases. W2 is constant. Then inside here goes down. This is positive, so this whole thing goes down. So Z1 goes down compared to Z2, which means that A1 goes down compared to A2, which means this thing goes down, which means this thing goes down, which means Z1 goes down even more compared to Z2, and so on. And we head off to the corner. Yep. So it's not stable. Instead of when this is negative, if W1 goes up, then this goes down, this is negative, so this goes up, Z1 goes up, and that tends to compensate and take us back towards the stable point. When this is positive, instead, you get this runaway effect, right? That one input gets more expensive, let's not bother investing in that input. So effectively the input gets even more expensive per effective unit of the input, and so on. And we end up only using input 2. So the only stable points are the corners given the independent knowledge stocks, where we only use one of the inputs and not the other, the cheapest one. Okay, effectively. well, it depends where we start actually. If we start here, we're going to go to this corner. If we start here, we'll go to the other corner. And this has huge policy implications, right? So you could say, well, if we're already at the corner, we're kind of done for, right? Because it's going to be ridiculously expensive or impossible to get over. But if we're just here and heading this way, but for some reason we think, as a regulator, we think actually it's better to be using input 2 instead of input 1, then we need a regulator to step in and encourage research for a little while in input 2 to get the input 2 costs down, to then let the market take over. Okay. The problem again is that the independent knowledge stocks model doesn't make sense. If we think of fossil fuels and clean energy sources, for instance, we've had fossil fuels for the last 100 years dominating energy supply. So according to the model, then we should be way down here, and it should be incredibly hard to switch to other energy sources. But in fact, just a few years research, even though we've got 100 years of fossil research, just a few years research and we can start having wind and even solar becoming competitive with fossil in the right circumstances. Okay, certainly not like hundreds of years behind. And the reason, of course, is that we don't have independent knowledge stocks. The wind researchers today can stand on the shoulders of, let's go see if I can find, yeah, it's not like this, with these being the wind researchers hopelessly behind, 100 years behind. It's like this, suddenly we decide we need wind research or wind productivity, and they can build on hundreds, thousands, millions of inventions over the last 100 years, which have happened since we last did wind research. We don't have to go back when we start thinking about wind research again for the first time for 100 years. We don't have to go back to wooden windmills with cloth sails and horses turning them round to face the wind, right? We're not interested in those old designs. We're not getting out our like feather pens, our quills and our parchment to write on to do our research either. We're getting out our computers. We're looking at propeller planes, turbines, etc., metallurgy, and so on. All sorts of stuff that's been discovered over recent decades that we can immediately apply to much more productive wind technology. So that's why this picture is wrong. And it's actually much easier to shift from one technology to another than is implied by this model. And there's less of a need for policy specific to the research sector. The big need is to fix other market failures, which we'll come back to. Obviously, in the fossil fuel renewable thing, the big market failure, of course, is the failure to price carbon, right? And that is far more important to fix that than it is to fix any problems within the research sector. It might still be worth doing something in the research sector, but the big deal is fixing the carbon price. Whereas this model with independent knowledge stocks suggests that fixing the research sector, if we can just fix that, we may not even need to price carbon, because we just got to get the ball over the hill. Okay, that is the end of that video, and then we have one more video on this section on alternative resource inputs, and then we move on to summing up on DTC very briefly, and then structural change.